Good morning, students. In the last class, we have taught about BCS theory of superconductor. In this class, we will discuss about the Josephson effect and tunneling. Before going to detail into the section of the Josephson effect and tunneling, we need to understand the behavior of the junction between the superconductor and the normal material. That is the metal superconductor junction. Okay. Metal, this is metal, and this is the superconductor. If we apply the voltage, what is the behavior of the current voltage graph? Okay, this is the interface between the metal and the superconductor. Actually, this shows the non-ohmic behavior. We know that in a conductor, we apply the voltage, we will get a linear graph. But here, we didn't get this type graph. Actually, we will get, this is I plotted along, this is V. Okay. At 0 voltage, if we are not apply the voltage, that is at 0 voltage, there is no current. That is up to a certain value of the voltage, this current is 0, up to a certain value, both in the positive direction and in the negative direction. That is up to a certain value. The I is 0. Okay. And only beyond this voltage, this current is going to rise. Okay, that is up to a certain value of the voltage, I is 0, whether it is in the positive direction or negative direction. Only beyond this value, beyond this threshold value, I is increasing. This is the non-ohmic behavior. That is up to this, I is equal to 0. ഇനി എന്തുകൊണ്ടാണ് ഇതിൻ്റെ ഒന്ന് തിയറി ഇതിൽ നമുക്കൊന്ന് മനസ്സിലാക്കാം. എന്തുകൊണ്ടാണ് ഇങ്ങനെ ഒരു ബിഹേവിയർ വരുന്നത് എന്ന് നമുക്ക് നോക്കാം. ആക്ച്വലി ഇതിൻ്റെ ഒരു എക്സ്പ്ലനേഷൻ നോക്കിക്കഴിഞ്ഞാൽ, ദിസ് ഈസ് ദി superconductor. Suppose this is the Fermi level. Okay, this is the metal. Here this is occupied state. This is the interface. This is the vacant state. This is difference band gap, that is 2 delta. In the case of the superconductor, there is no single electron states are available. So this band gap, that is 2 delta around the Fermi level, there is no possibility of the individual electrons. According to BCS theory, all the electrons are paired, ഒരു കൂപ്പ പെയർ ആയിട്ടാണ് ആക്ട് ചെയ്യുന്നത്. ഓക്കെ, ഇവിടെ സപ്പോസ് ഒരു ഇലക്ട്രോൺ, ഇവിടെ ഒരു ഇലക്ട്രോൺ എന്ന് കരുതുക. If the voltage is 0, നമ്മുടെ വോൾട്ടേജ് 0 ആണ്, ഇലക്ട്രോൺസ്, we cannot send electrons from this state to this state, from 1 to 2. We cannot jump from this to this, because in the complete occupied state ആണ്. ഇനി നമ്മൾ വോൾട്ടേജ് കൂടുതൽ കൊടുത്തുകൊണ്ടിരിക്കുമ്പോൾ എന്ത് സംഭവിക്കുന്നു? metal vacant state. This is the occupied state. Okay. Only when the top of the occupied level in the metal side comes equal to the vacant side. Okay. Only, once again, only when the top of the occupied level in the metal side comes equal to the vacant state. So here an electron can flow inside the system. There is the possibility of the transfer of the electron. Okay. Again, at a higher voltage we get ohmic like response. See, this is the jump. This is the transfer from the 1 to 2, that is from the top of the occupied level comes equal to the vacant state. There is transfer of the electron from 1 to 2. Okay, at higher voltage we get ohmic like response. So there is the possibility of the electron scattering. So there is a resistance in this region. Okay, ഈ ഒരു റീജിയനിൽ നമുക്ക് കറണ്ട് 0 ആയിരിക്കും. ഓക്കെ, ഈ ഒരു ബിഹേവിയർ ഒന്ന് മനസ്സിലാക്കുക. ഇനി നമുക്ക് ജോസഫ്സൺ ജംഗ്ഷൻ എന്താണെന്ന് നമുക്ക് നോക്കാം. ഓക്കെ, Josephson effect and tunneling. Okay. Actually, there are many effects associated with the tunneling of the superconducting electron pairs from one superconductor through the another superconductor. This Josephson effect, there is an insulating layer that is sandwiching between two superconductor. Okay, so it is the effect associated with the tunneling of the superconducting electrons through a very thin insulator that is sandwiched between two superconductors. Such an insulating layer forms a weak link between the superconductor, which is referred to as Josephson effect. So there is one superconductor and there is another superconductor, a thin layer of the insulator that is sandwiching between the superconductor. This is the insulating layer. നമ്മൾ ശ്രദ്ധിക്കേണ്ട കാര്യം എന്താണെന്ന് വെച്ചാൽ ഇൻസുലേറ്റിംഗ് ലെയറിൻ്റെ thickness that is of the order of the superconducting coherence length. Okay, that is approximately 10 to 100 nanometer. Here we can measure the voltage and here apply. Okay, here we apply the voltage V0. So note that there is an insulating layer. The thickness of the layer is of the order of the superconducting coherence length that is sandwiched between two superconductors. Okay, ഇനി ഇതിൻ്റെ ബിഹേവിയർ എന്താണെന്ന് നമുക്ക് നോക്കാം. if here even at the zero voltage കൊടുത്താൽ പോലും, അതായത് in the absence of the voltage, we will get current in the system. Okay, and this case is absent in the case of the metal superconductor interface. Metal superconductor and behavior നമ്മൾ സ്റ്റഡി ചെയ്തപ്പോൾ V equal to 0, അതായത് ഇൻ ദ ആബ്സെൻസ് ഓഫ് ദ വോൾട്ടേജിൽ നമുക്ക് ഒരു കറണ്ട് കിട്ടിയില്ല, ദാറ്റ് ഈസ് I equal to 0 ആയിരുന്നു. ഒരു പർട്ടിക്കുലർ റേഞ്ചിൽ നമുക്ക് കറണ്ട് 0 ആയിരുന്നു. പക്ഷേ ഹിയർ ദ കേസ് ഈസ് ഡിഫറെൻറ്റ്. ഹിയർ ഇൻ ദ ആബ്സെൻസ് ഓഫ് ദ വോൾട്ടേജ് ദർ ഈസ് ദ പോസിബിലിറ്റി ഓഫ് ദി current in the systems. That is here when V equal to 0, I is not equal to 0. There is the possibility of the here the resistance is 0 in the system. Now what is the reason for this? That is for V equal to 0, there is I. There is the current flowing. What is the reason? Okay, see, this is the superconductor. This is the thin layer of the insulator. And now I and the mark here, and another superconductor S2. Okay, this now a wave function the terms we explain. Suppose this electron have the wave function. Here also the electron have the wave function. Okay, this is the thin layer of the insulating layer. Keep it in mind that the thickness is of the order of the coherence length of the superconductor. Okay, here the wave function from S1 leaks. There is the possibility of the leaking of the wave function across the boundary. So obviously it can enter into the other superconductor S2. Okay, similarly there is also the possibility of the leaking of the wave function from S2 through S1 to S1 through the insulator I. Okay, so obviously there is an interference. Okay, there is an interference of the current that is flowing across the junction, or we can say the Cooper pairs are tunneling across the junction. So obviously we will get current across the junction without applying the voltage. Okay, that is the DC Josephson effect. That is, according to DC Josephson effect, a DC current flows across the junction even when no voltage is applied across it. That is, once again, the wave functions are interfering in the junction. The junction has the thickness is of the order of the coherence length. That's obviously leading to the flow of the current. And that current, that is I is equal to I0 sine delta, and the voltage V is equal to H cut divided by 2E d by dt of delta. Okay, what is delta? Delta is the phase difference across the junction. And wave function phase difference ആണ് ഈ ഡെൽറ്റ കൊണ്ട് ഉദ്ദേശിക്കുന്നത്. And I0 is the junction critical current. And also note that this voltage, the voltage is directly proportional to the rate of change of the phase difference delta. Okay, and what will happen when we apply a constant voltage? When we apply a constant voltage, this is constant. When we apply the constant voltage, this delta, that is directly proportional to V0t. So obviously I is equal to I0 sine of, there is a constant, we call it as constant as B. that is V0t plus delta 0. So surely this shows an AC effect. Okay, this shows an AC effect. Okay, if we apply a DC voltage across the junction, RF current oscillations or AC current oscillations of frequency F is equal to 2EV divided by H are set up across it. Okay, now we are going to understand about skewed, that is macroscopic quantum interference. It is the arrangement. Okay, I just draw the arrangement which is known as superconducting quantum interference device, that is skewed. Here there is an insulator layer. Here also there is an insulator layer. Okay, macroscopic quantum interference. This effect describes the influence of the applied magnetic field on the supercurrent flowing through the junction. Okay, this shows what are the effects of the magnetic field on the supercurrent that flows through the junction. From where we will get this supercurrent flowing through the junctions? That is purely due to the interference of the wave function associated with the Cooper pair. Okay, according to this effect, if a DC magnetic field, if we apply a magnetic field through the superconducting circuit, it contains two junctions, two Josephson junctions, the maximum supercurrent flows interference effect. Okay, there is the possibility of the maximum flow of the supercurrent. It shows interference effect. And that interference effect depends on the intensity of the applied magnetic field. കൊടുക്കുന്ന magnetic fieldനെ depend ചെയ്യുന്നുണ്ട് ഇത് supercurrent. Okay, so consider this type of arrangement. This is known as skewed, that is superconducting quantum interference device. It consists of a ring of superconducting material having two side arms A and B, which act as an entrance of the superconductor, and this is the exit for the superconductor. And this is the insulating layer P, and Q is also the insulating layer. In general, they have the different thickness. Let the current flow through these layers be I1 and I2. And the variation, this both I1 and I2 vary periodically with the magnetic field. Okay, since this current is very sensitive to the small changes of the magnetic field. So this device can be used as the very sensitive galvanometer. Okay, this I1 and I2, it is very sensitive to the magnetic field. Small changes are in the magnetic field. Okay. Actually, this Josephson effect, they are the consequence of the superconductor. Okay, that is characterized by single wave function. And this Josephson effect exhibit this interference phenomenon, that is on the macroscopic scale. Okay. അടുത്ത ക്ലാസ്സിൽ ഹൈ ടി സി സൂപ്പർ കണ്ടക്ടേഴ്സ് എന്താണെന്ന് നമുക്ക് നോക്കാം. സോ ജസ്റ്റ് ഒന്ന് സമ്മറൈസ് ചെയ്യാം. ഡി സി ജോസഫ്സൺ എഫക്റ്റ് എന്ന് പറഞ്ഞത് എ ഡി സി കറന്റ് ഫ്ലോസ് അക്രോസ് ദ ജംഗ്ഷൻ in the absence of the any electric and magnetic field, whereas in the AC Josephson effect, DC voltage is applied across the junction that causes radio frequency current oscillations across the junction. And this effect, that is very precise, that is utilized for the precise measurement of the factor H divided by E. Okay, so this is very useful. Further, a radio frequency voltage we apply with the DC voltage, it causes an AC current. It have the frequency F is equal to 2E divided by H cut.